Hello. Shall we start? Today we are going to talk about the LAB3. So LAB3 is a very interesting one. You need to collect the data by yourself and do the similar thing of LAB2, do the reporting and write down the comment on that. But you may have a lot of trouble on like plotting the graph. So let's just have a look of it. Before we go to the data collection here, we shall open the specification of it. Allow me to have 1 sec to open it. Here. Okay, let's have a look of the specification here. So you can see a very important word for this lab is line of sight, which means we are required to collect data in the environment of line of sight. So what does this mean? Does anybody know this? LOS? So we have already learned something in the lecture, right? About the line of sight. Do you still remember that? Direct path between transmit and receive. That's correct. So what should be in our mind is we should keep our environment always be line of sight. So how can we do that? Because we need to collect some data by ourselves, right? So in order to apply the environment of line of sight, we should always make sure the hotspot and our laptop, there is nothing between it. So we will talk about that later. So in this lab, we are going to have a look of how to capture the data by ourselves. I think some students already collect some data by themselves in lab 2, right? I think most of them have at least tried. Does anybody have some question related to that? Like if you have like a configuration problem or you cannot capture the data by yourself, or you are not able to capture the noise level or something else, you can put it on the chat channel. So in the lab 3, we are using our own data set to make the report. So you can see your task. The first one is to capture the data. And then you are required to like plot some graph, write down a report of it. There are two parts of this lab. So let's have a look of this part at first. So what we require to do is to have 3 steps to collect the data. So at first, just configure your Wi-Fi hotspot. So simply is just create a hotspot with your mobile phone or something. that you can use your laptop or desktop to connect your hotspot on it. And let's go to the next step, which is like collect 10 different data sets from 10 different distance. Let me have a small picture here. Let me show you on the picture. So what should we do in the step 2? You can see there mark 10 equally distant spots here. So what does this mean? And it says indoor and outdoor area. So what we need to do is we assume the environment is indoor, and then this one is your laptop. Let's say your laptop here, and you can put your mobile phone at the other corner. And Wi-Fi hotspots here. Let's say it's your room here. You can put your laptop at the corner of your room and put the mobile phone at the another corner of the room, and then you can make a straight line from the mobile phone to the laptop. And what you need to do is you should put some like label on the ground or somewhere to split this line into 10 pieces. So why do we put some label on the ground or something? For example, I put only 2 here. So what you need to do is you start to collect at the longest distance here, and then you move your mobile phone to another spot on the mark on the ground and start the collection again, and so on and so far. You need to do this 10 times, and you can get 10 data sets on your computer. Does that make sense? So let's have a look here. What you need is a mobile and a laptop. You may use your desktop to collect the data, but you should be aware that we are going to the outdoor for the data collection. So if you only have a desktop, you may have some trouble on outdoor collection. So I suggest you to borrow or use a laptop to do the collection. And for the Mac and Linux environments, we are going to use Wireshark to help us to do the data collection. And for the Windows 10, we are going to use the network monitor, which is this one, do the collection. Okay, just the same as LAB2 task 2. So what we need to capture is both indoor and outdoor environments. For each environment, we need to capture 10 different distance and save it as a CSV file. So let me have a demonstration here. What we need to do is, for example, I am in like this. This is my laptop here, and I connect my laptop with my mobile hotspot and put the mobile phone at another corner of my room, and then I can start to play a YouTube video, or I can just simply use the command of ping the mobile hotspot server, which is this address, and use the just input a large number of it to make sure we are continuously ping my server. And then I can use, let's say, the network monitor to stop the capturing. All I need to select is to select the Wi-Fi and stop capturing. Click here, new capture, and click the stop button. You can see there are lots of traffic display on here. And let's just wait for 1 minute. For example, if we have already waited for 1 minute, so we can stop and save as a new file. Let's say LAB3. And then we are able to open it with the Wireshark. Open the file. LAB3. Sorry, where's the file? It's already here. Open it. See? So with my adapter, I am only able to capture the UDP and TCP packets, which is fine. We can still use the UDP and TCP packets to do this lab. It doesn't really matter. You can see after the capturing, I am able to find some signal strength in the data set. So let's just use this data set as our data set. You can apply a filter before you save it into the CSV file. Does that make sense? And you need to do this thing like 10 times for each environment. And you can get totally 20 different CSV file. How big does the room need to be? I think there is no requirement on the lab. So if, for example, your room is pretty small, let's say only 3 meters from your laptop to the mobile phone, all you need to do is just split them, split the distance, split this line into 10 pieces. You can mark 10 spots on the line, like for example here, I mark 10 here. And so on and so forth. You can keep putting the mark on the ground. And then after the collection here, you just move your mobile phone to this spot and continue your data capturing. Does that make sense? But what you need to do is you need to have an estimation of the distance from your laptop to the mobile phone while you collect your data. So you can go to the outside of the room, like go to the outdoor and keep using the same distance. Is that okay? For example, the distance from the longest distance from your laptop to your mobile phone is only 2 meters for indoor. So when you go to the outdoor, you're still using the like maximum 2 meters from your hotspot to your laptop to collect the data in the outside. My signal strength was the same for every packet captured. Is there an error in the adapter? I don't think so. Did you like have you ever tried to move your laptop from your hotspot? If you like put something like between them, the signal strength may be different. Yes, you did. Okay, it seems really weird because we can easily find the difference on the signal strength if you like waving your hand or put some object between it. Maybe, yeah, probably you can like post your problem on the forum, or you can show me later on. If we will have some spare time after the lab, so you can show me your screen and tell me how you capture the data. Yeah. And how can we do it on Mac? Okay, on Mac and the Linux is more simple. So what we need to do is like let's back on here. What I need to do is I place some marks on the ground at first, like place 10 marks. I only place 3 here. Then you need to play 9 or 10 here. So including this one is 10. So let's back to this situation. I put my mobile phone at the corner of the room. And what I need to do is I can open a YouTube to play some video to increase the traffic between my laptop and mobile phone so we can collect more data. Does that make sense? And what we need to do is play some video online and open the Wireshark and select the adapter you want, right? And don't forget to like open your monitor mode before you turn on the capturing. You can open the monitor mode here, but I'm using a Windows 10, so which is not able to open the monitor mode. So that you can see there's no signal strength here. That's the reason why we need to use the Windows Network Monitor to help us to capture the packets. But if you are using the Mac and Linux, you are not required to use that software. You can capture the packets with Wireshark directly. And after the capturing, you can just simply apply a filter to delete all the unnecessary packets and then save it as a CSV file here. Okay. So we just wait still for at least 1 minute in each capturing in 10 different distance. Yes, you're right. You can see how much packets did you have. If you think it's enough, so you can stop it. So after the data collection, we will have 20 different CSV file. Yeah, and another important thing is we need to maintain the LOS condition, which means you should have nothing between your laptop and mobile phone. For example, our room is very crowded. I have a sofa inside my room. So I need to make sure when I collect the data, there is nothing, including the chair, the sofa, and anything between my laptop and my hotspot. Does that make sense? Does anyone have any like problem in this stage? So this step is quite simple. It's just very similar as the LAB2. So I guess we are good. You can see after the collection, we will have these files, 10 files. For my collection is 1 meters to 10 meters. So I will have this CSV file in my desktop, and I can use them to plot the graph on the report. So what should we do in the report? We are required to plot some graphs based on the CSV files. Let's go to the specifications here. We go to the next part. So what we are required to do is, in the first part, we are going to plot the RSS data against distance in log scale. This one is important. So you are required to plot something like this. The y-axis is signal strength, and the x-axis is distance in log scale. You can see here. Because I'm using the 10 meters as my longest distance, so the log scale is 10. Does that make sense? So we are going to plot two different graphs. The first one is just plotting the raw RSS data, and the second one is plotting the average RSS data. And we also need to like use the linear regression to draw a line on our plot and then calculate the R-square value of it. And after all, we are required to write our commentary that just like tell the difference between the indoor and outdoor data set. Let's go to this part so you can have a clear see on it. So after we got the CSV data, we are able to plot them with like Excel or Python and whatever tools you want. The first plot will be like this. You can see there are lots of scatter on the graph. This one is for the let's say 1 meters. And this one is for the 2 meters, 3, 4, 5, 6, 7, 8 to 10. And the second graph will be like this. You can see the x-axis and y-axis is the same, but we only use the average value of each distance to plot our graph. And then we can use like linear regression to get the slope value. And calculate the R-square value of it. Is that okay? But you should be aware of that the graph here is only for reference. You are not required to do the same stuff as mine because this one is not pretty good. For example, I made some mistake on the collection here. You can see the signal strength is even stronger than the shorter distance here. You can see this one is for 1 meters, right? And this one is for 10 meters. And this one is for 8 meters here. And this one is for 7 meters here. I made some mistake on the 8, 9, and 10 meters. You can see the signal strength on 8 meters is even better than 7 meters. Why? Because I just made a mistake on the collection. Like I make the wrong distance or something else when I do the collection. So what should I do in here? What I need to do here is just drop the outlier if needed. We call this kind of invalid data as outlier. So what we need to do is when we calculate the slope, we are not consider these 3 invalid data here. but this is only my data set. Your data set may be very like perfect, and you may not require to drop any outlier. So, but if you have any outlier like this, you can drop them and make your slope better. Okay. Do you have any question related to that? You can see the details here. If we have some outlier, we can drop them when we fit in the line. So the graphs here is just for reference only. You are not required to draw a plot exactly the same as mine. Okay. And don't worry if you got a different value as mine. Why would the signal strength vary so much at the same distance on the left graph like this? There are lots of reasons for that. You can find it on the lecture slides because there are some the signal strength is from the reflection, and some are on the light of sight environment, right? Like let me have an example here. So most of the like would be this one. Let me use the pen here. So why are they so different? It's because for most of the signal, we go like in the straight line, right? But some like signal will be like this and reflect into your laptop. And that's the reason, one of the reason why we got a different signal strengths. So you can see there are a lot, the range is very wide, but you can see the average is in the middle here. So we can see most of the signal strengths will stay in this area. That makes sense. And can you talk please about the linear regression, how to calculate it? Okay, so I'm using the Python to help me to calculate the linear regression. There are much lots of way to calculate a linear regression. So what I do is I use the numpy dot polyfit to help me to calculate the regression, and you can have a look of the documentation. But I cannot show you the codes because if I show you the codes, everybody just do the same way. But you can have a look of the numpy.poly feed. This one is pretty easy to use. All you need to do is just insert the X array and the Y array. And then it will just return the value of M and Y. It will return these two values to you. Okay. Like our X value is the distance, log distance, and our y-axis is the signal strength. So we got both of them in the data set. All we need to do just to make them as an array and put it into the numpy.polyfit. But you can also use Excel to do that. You are not required to do any programming thing. But if you would like to do this, you can use this numpy.polyfit to help you to plot the line. Okay. So if you have further question related to the linear regression, just feel free to post it on the forum, or you can come to my next tutorial and ask me online. By the way, if you want me to find me on the next tutorial, I can give you this link. The link here. So here is a timetable of our tutorial. So you can feel free to join any tutorial if you want. Like if you have any lab question today, and you feel you want to get the answer from the tutor, you can join any tutor lab and then ask them the question. And you can also find the recording link here. Then you'll be able to find the lab recording here. Okay. So I will also post some like lab information like the key steps and the general question on this link. Let me send it to the chat. What is the difference between a beacon package and the other package? Are signal strength data only provided in beacon package? Yeah, you can find there are lots of packets that we capture here. Yeah, for this one, it doesn't have any stuff. Let me open another one. This one. You can see there are some packets doesn't have any like wireless information, the radio information here. So what we need to do is we need to apply the filter to get all the packets from outside to our laptop. So you can see the IP address of 192.1.8 is my laptop, and this one is probably the Zoom server, I guess. So all I need to do is apply a destination filter and get all the useful packets I need. So all you need to do is just make sure the destination is your laptop, and then you are good to use the package. Is that okay? Okay. So for the linear regression, it doesn't really hard to do that. All you need to do is just use some tools to help you to calculate it. So if you find any trouble on it, just feel free to ask the question on the forum, or just come to me and ask me. I will try my best to help you. So you are not required to learn any knowledge related to this. So do not spend a lot of time on it. And let's go the next part here. Yeah, here. Some general question. Is this one? This one. How to calculate the R squared? So you can have a look of here. We are required to calculate the R squared value, which is between the 0 and 1. So why should we do that? Does anyone know R-square value is. So the R-square value is basically a measurement of the correlation of the regression model. So if you don't know it, just don't be afraid of it. Just a kind of measurement for our regression model. And how to calculate it is we can simply use the calculator online. You can search by yourself on Google, or you can open this link, just input some data we have. For example, here, I use my distance as my x array. We can have a look here. You can see. The first one is 0, which means 0 meters. And for 1 meters in log scale is about 0.3, let's say 0.3. And the next one is 0.5. And then you can put the average value here, like let's say minus 28. And this one is minus 42. And this one is minus 47. And then you can click the calculate. And then you will get the R-square value. And all you need to do is just put the value into your report. That makes sense? Or you can calculate by yourself. There are lots of methods to calculate the R-square value to it. Or you can use Excel to automatically generate the value of it. Can we still filter SSID on Windows Network Monitor? Of course you can. Why I didn't use SSID as my filter here? You can see there's no package that have my SSID. So my adapter are not able to capture the SSID information here. So that's the reason why I didn't use my SSID filter. But you can use the SSID filter. So there are still some student doesn't have any package in their while they're capturing. Like they are not able to capture the package through the Wireshark or the network monitor. So what should we do? So at first you need to check, make sure your configuration is correct. Like here, open the monitor mode is the first one if you are using the Mac or Linux. If we are using the Windows 10, we are going to use the network monitor and make sure the configuration here is correct. We only choose Wi-Fi. You can see the killer is my interface, network interface. And I can find my IP address here. And just click new capture and start. If you still have something like you are not able to capture the package, just post it as soon as possible so we can help you. And after you can, if you make sure you have all the configuration correct, but you still not be able to capture any like package on your computer, maybe you should borrow a laptop from a friend or you use your old laptop to do this. Or you can just simply buy a wireless adapter like this one. I'm not making any kind of advertisement here, but you can buy a like very cheap wireless adapter to help you to get the package. So if you are if you want to capture all the data like the noise level, signal to noise ratio, you can buy a wireless packet, wireless adapter here. But we are not going to use noise level and signal to noise level in the future labs. So don't worry about if you are not able to capture all the noise level or other stuff on your computer. So in the future labs, we are only going to use the signal strength. And you will not be penalized if you are not able to capture any kind of signal noise level or signal to noise level stuff. Is that okay? And that's all for the lab, I think. That's all I can say. So if you have any question related to the lab, just feel free to ask me. I will stay here to the end. But if you doesn't have any question, just feel free to leave. Can I ask question regarding to the quiz? If you have any question related to the quiz, you can post it on the forum so we can reply you as soon as possible. Oh yeah, so if you would like to have a preview of the quiz, maybe I can upload some like previous quiz like from last year or 2 years ago to on the GitHub link. So you'll be able to have a practice before you go to the real quiz. I hope that this will help you. I will upload a quiz into the GitHub here after this tutorial. Yes, maybe you will find the quiz in the first week and the second week is a little bit hard. But the like the quiz in later on is will be easier than the first 2 weeks because in this first 1 and 2 labs we have a lot of calculation on here. But in the later quiz we don't have lots of complicated question. So you will get the full marks, I guess, in the future quiz. And you will be able to get the lab's grades in the end of this week. Can you clarify what is LOS, please? Yes. So LOS is line of sight. So if you don't know what is this, you can have a like review of the lecture notes. So basically, what we need to do, why we're talking about the line of sight? Because we don't want any stuff between the. Let me open the page. Can't find it. Between the laptop and hotspot. Yes. Okay. So this is your room. So what is the LOS condition? I say this one is your laptop, and this one is your hotspot. It's probably your mobile phone, right? And if you are start to capturing the data right now, so you should not put anything like you should not stand here. So you should not stand between them while the capturing. Okay, so you should stand aside, and you should, for example, you have a table here. So you should move the table away to make them there are nothing between them to make, to make sure the LS condition. Does that make sense? So the line of sight, pretty straightforward. In the point of laptop's view, you are able to see the hotspot. And there should nothing between them. And you should always be careful of the height of the laptop and hotspot. Maybe you should put them in the same level. I mean, if you put the hotspot on the table, you should also put the laptop on the table so they have the same height. And the same in the outside environment. So does LOS means that you should not have any obstacles between the laptop and the mobile phone? Yes, correct. So for example, you have a table between them. You should move it away to here. Okay, yeah. Does it mean we just need to make sure there's nothing between them? Yes. Actually, it's pretty simple, isn't it? Just do not stand between them. Uh, After you start the flexion, you should stand aside instead of between them. And you should also remove all the thing between them. So does anyone have configuration problem? So you can show me now. You can share your screen or you can send me a picture of it. You should better to share your screen if you want. So are you able to share your screen here? Just want to double check if I am on Windows, I can just use the TCP ISO for labs. Yes, if you are using the Windows and you are not able to capture the AO 2.11 protocol, which is the raw wireless packet on the network monitor, then you can use the TCP or UDP packet to do this one. For example, here, I'm not able to capture the package, the raw package here. Then I can use the package like this. You can see it's a UDP, right? But it still have the signal strength, and it's from outside to my laptop. Then I can use it. And some wireless adapter can show the SSID, so you can use them as a filter. But here I use my destination as my filter. Just want to double check. Yeah, is that okay? Feel free to stay here if you have any question when you are doing the lab. So you can ask me question at any time. I will stop the recording now so you can share your screen, ask the question if you want.